All right, so the first thing I want to do today is just practice a bunch of problems, but I want to take a look at the graph of this function. We have a third root of x squared minus 1 quantity squared. How can I type that into a graphing calculator? No, without typing it into a graphing calculator, how can I type that into a graphing calculator? Good. So we want to rewrite this anyway, because that's how we're going to take the derivative. As soon as you rewrite it, you can probably see what rule we're going to have to follow. But this becomes x squared minus 1 raised to the 2/3 power. You have to remember how to work with fraction exponents, right? Rational exponents. This is the numerator, this is the denominator. Okay? All right, so let's graph this now. So when I graph this, I get this. Kind of looks like a weird W. Okay? Is the function continuous? Yeah, we kind of should know that from the original function over here. There's no division by 0 anywhere. And this is not a piecewise or anything like that. So this is a continuous function. When I look at it, the graph does look continuous. Is it differentiable everywhere? So this brings up something that we talked about back in chapter 1. Or actually section 1, sorry. Yeah, we have a point here. It comes to a sharp corner right there. And also right there. You can't put a tangent line at a sharp corner. So that means that the function is not differentiable there in either one of those two places. What values do those look like? Looks like 1 and -1, okay? So I just wanted to bring that to our attention before we start taking the derivative. We'll analyze the derivative graph as well, okay? Here we go. So I've rewritten this thing. Want to take the derivative. What should I do? Huh? Yeah, what's this called that we're doing? It's the chain rule. In fact, in this particular case, this would be the what? It's the general power rule. Okay? So to do the general power rule, we're going to have f prime of x equals, what happens here? The 2/3 comes down. Then what? What's inside stays the same. Then what? 2/3 minus 1 is -1/3. We decayed the 2/3 by 1, and it becomes -1/3. Then what? Times the derivative of what's inside, which would be 2x. Okay, now we're going to have some simplifying to do and also some rewriting because we have a negative exponent. So, f prime of x equals the 2/3 out front and the 2x at the end combined to become 4x over 3, right? Okay, so I have 4x over 3, but I also have this whole thing going in the denominator. So I'm going to do that now. Over 3, parentheses, x squared minus 1 to the 1/3 power. Yeah, it would be the cube root, but I'm going to leave it as the 1/3 power. Okay, so that is the derivative function. That's the answer. Let's go back and graph this thing now. We can get rid of the other function probably. Let's leave it on there because we can. Let's graph this one. So there it is. Kind of a cool looking function, I think. But what do you notice about this graph? Talking about the red graph now. What? What do you see?
Right where the point is on the original graph, it's
Uh-huh.
like a vertical. Like that's where the red graph.
Yeah. There's vertical asymptotes here on the derivative exactly matching up with where we had a non-differentiable situation on the original function. Okay? And why is that the case if I look back at my derivative? There's division by 0. Where is there division by 0? When x is exactly 1 or -1. Okay? So the derivative function is very closely tied to the original function. If we have a non-differentiable situation in the original function, in the derivative you will see division by 0 most likely. Okay? kind of an interesting result, I think. So in this function, where does f prime of x not exist? 1 and negative 1. You can see that from right here when x equals plus or minus 1. You can also kind of assume it from the graph, but again, that's a dangerous thing to do. You can see in the graph that there's a vertical asymptote, and then that will help you realize that I can do the algebra here to come up with where that vertical asymptote is. Okay, another type of example that we could have here would be a problem like this. Now, you could solve this two different ways. You could say, okay, I have a rational function here, so I could use the quotient rule. Or I could try to rewrite this thing and avoid the quotient rule and just go to the chain rule. Either way, I'm going to have to rewrite. And actually, if I do the quotient rule, when I take the derivative of g, I'm going to have to use the chain rule anyway. So try to rewrite it to make yourself eliminate a couple of steps along the way. G of t equals, what can I write? There you go. Now it's not written like a rational function anymore, which makes life a lot easier. So if I take the derivative of this, what will I have to do? This is a general power rule again. So g prime of t equals positive 14 So the negative 2 comes down, becomes positive 14. What's inside stays the same. Subtract 1 from the exponent. The derivative of what's inside is 2. Simplify. So g prime of t equals the 14 times 2, which is 28. I see that this is going to go to the denominator, so I'll put that 28 in the numerator, divided by 2t minus 3 to the third power. So that's the derivative. Pretty straightforward, if you know how to do it. So that's enough of the easy stuff. Let's go on to something tougher. We have a simplifying technique that I've been hinting at. It's called the least powers simplifying technique. When you are done taking the derivative and you get the algebra all the way down, you think you're done, but you got a couple of terms sitting around, maybe 3 terms sitting around, you might factor out a GCF using the least powers, and that will simplify your answer even further. And that's going to start here, and you need to know how to do it from now on. So let's take the derivative of f of x equals x squared times x minus 2 to the third power. What rule do we need to use here? Good. We need to use the product rule because we have a function times a function. You have to recognize that. Okay. So once you see that it's the product rule here, then you start going. And if you encounter other things that you have to do when you're taking the derivative along the way, then fine, so be it. Do it. But you got to start off on the right foot. So the product rule again is what? F prime g, g prime f. Good. So that's what we're going to do. F is my x squared, g is my x minus 2 to the third power. So my function f prime of x will be what? Now I'm going to write this in a formal notation here. I'm taking the derivative with respect to x of x squared. We know that that's 2x, but I want to write the formal notation. You'll see why here in a second. Times what? Okay. Plus the derivative with respect to x of x minus 2 to the third power times x squared. Okay. Now the reason that I wanted to write it like that is so that we could see. Right here, we can take that derivative very easily. That's just a regular derivative, power rule. Right here, that is not a regular power rule situation. We're going to have to do what here? the chain rule. And in this case, the general power rule. So we did the product rule to set up the derivative, but as we're taking the derivative, we're going to have to do a new rule in order to get that derivative taken. Okay? So, what's that? Okay. So now we just take the derivatives. We have 2x times the x minus 2 to the third power. And now we're going to take this derivative using the chain rule, which is also something that we can do in our head. We just have to recognize that we are doing the chain rule here. So we're going to have plus what? The 3 comes down. The x minus 2, the thing inside stays the same. The exponent decays by 1 times the derivative of what's inside, which in this case is 1. And then don't forget, you're also multiplying times x squared at the end. Okay, now the calculus is over. It's just algebra from here. So f prime of x equals, I can't simplify this any further just yet, so I'll write 2x times x minus 2 to the third power. This thing here can simplify. I have a 3 times a 1 times an x squared, so that's plus 3x squared out front times x minus 2 quantity squared. There is a GCF here. There's more than just x as a GCF. Remember, we're working with least powers here. So f prime of x. Take a look at the stuff outside first. Is there a GCF between 2 and 3 that's not 1? No, so we'll leave that alone. Is there a GCF between x and x squared? Yeah, it's what? X. So I'm going to pull out an x. And now look at the third part of this. Is there a GCF between x minus 2 to the third and x minus 2 squared? X minus 2 squared. And that is how you do the least powers. The least power between x and x squared was x to the first. So that's why we factored out x to the first. The least power between these two guys here was that squared. So that's why we're factoring out the x squared, x minus 2 quantity squared. Now when you factor out a GCF, you open up parentheses and you tell what's left over. So if I pull x times x minus 2 squared out of 2x times, well, the 2 is definitely still there. The x is gone, but what about the other thing? There is still an x minus 2. Plus 3x. And we pulled all of that out of there. So now I close my parentheses here. Usually when you factor out using least powers, what's left over will simplify in some way. So watch for that. If we distribute the 2 in, we'll be able to combine like terms. So that will be considered simpler. F prime of x equals the x times the x minus 2 squared times, this becomes 2x minus 4 plus 3x. So 5x minus 4 is your combined factor sitting there. We will not distribute that back out. That is the answer. Okay, find the derivative of this thing. What is the first thing we should do? Rewrite it. Get rid of that root. So this becomes f of x equals what? Good. Okay. Now we need to take the derivative. So what starts us off? Good. Again, it's the product rule. We have a function times a function. So worry about that first. Now, I could write it out in formal notation, but do I need to? No? Are we going to get lost along the way? Okay, I'll trust you then. F of x, f prime of x equals 2x to the 1/2. So this is f prime, the original g, plus We do need the chain rule for g prime. So, and then it's going to be times f. So what I'm going to do is I'm going to write down the f first so that I don't forget it down at the end. So x squared times 1/2. So the exponent came down times what's inside stays the same. To the negative 1/2 power, we have to decay the exponent by 1 times negative 2x, the derivative of what's inside. Close all the parentheses. So just to recap, that is f prime, that is the original g, plus that is f, and then we had to use the chain rule here, the general power rule, for the derivative of g. The exponent came down, what's inside stayed the same, decay the exponent by 1 times the derivative of what's inside. All right, the calculus is over. Now we got to simplify. F prime of x equals. For this first term, I can't simplify that just yet. So 2x times 1 minus x squared to the 1/2 power. Simplify over here before you try to find a GCF. So this will be what? It is negative because of the fact that we have a positive times a positive times a positive times a negative. So minus the 1/2 times 2 becomes 1. The x squared times x becomes x to the third. Parentheses 1 minus x squared to the negative 1/2. Don't lose stuff along the way. All right. That's as simplified as we can get until we start factoring out least powers. So f prime of x. Take care of what's outside first. What's the least power there? Look at the numbers. 2 and negative 1. There's no GCF there aside from 1. So we skip the numbers. Look at the variables. What? X. And then look at the binomial that we have there. X. So yeah, 1 minus x squared to the negative 1/2 is the least power there. Okay? All right, open up parentheses and write what's left over. We didn't factor out the 2. We did factor out the x, so we're not going to write that. We factored out an 1 minus x squared to the negative 1/2 out of this. So I am going to have 1 minus x squared to some sort of exponent. We don't know the exponent, do we? The trick to finding the exponent is this. So like off to the side, if I have a to the third times a squared, what do I get? A to the 5th. You add the exponents when you're multiplying like bases, okay? So if I were to distribute this back in, since these are like bases, I would have to add the exponents together in order to get that. So what I do is this. I take the exponent that I factored out and I add some exponent so that I wind up with the exponent that I started with in the first place before I factored. So negative 1/2 plus what gives me positive 1/2? 1. So this exponent must be 1. Okay, so we factored out all of that from that front term. Now we need the minus what? X squared. And is there anything else? No, that's it. We factored everything else out of there. So I close the parentheses, and then we can simplify usually, and in this case we can. Since that's just to the first power, then I can distribute that 2 in, and I get f prime of x equals the x up front, parentheses, the 1 minus x squared to the negative 1/2, parentheses. I distribute the 2 in and I have 2 minus x squared. Sorry, 2 minus 2x squared, and then minus x squared. So what do I get? 2 minus 3x squared. And those like terms are combined. Am I done? No, why not? Got a negative exponent. So f prime of x equals, this guy stays in the numerator, this guy goes to the denominator, this guy stays in the numerator, 2 minus 3x squared over, parentheses, 1 minus x squared to the 1/2 power. That was fun? Yeah, I think it's fun. It is fun. It's very fun. It's relaxing almost. That's your answer. I'll save you some struggling on your own, and we'll just struggle together. Well, you'll struggle, and I'll guide you through it.
Yeah.
I will. I will laugh at the confidence meter. No. You guys are doing just fine. Okay, find the derivative of this function. What do you see? See a quotient rule, definitely here, because of the fact that we have this and this. Or you could rewrite it and use the product rule. Okay? You're going to have to rewrite it anyway because of the root in the denominator. Okay? But let's use the quotient rule on this one. You can rewrite it and use the product rule, but in the end you have to simplify anyway, and you're going to wind up with something in the denominator as it is. So just use the quotient rule and avoid that. So I do want to rewrite this though, because I have nth root in the denominator. This becomes x squared plus 4 to the what power? To the 1/3 power. Okay, quotient rule. What is it again? Good. Let me jot that down over here. F prime g minus g prime f over the original g squared. Okay, take the derivative. F prime of x equals what? 1, that's f prime, times the original g, which is x squared plus 4 to the 1/3 power, minus, we're going to have to use the general power rule on g prime. So I'm going to take care of writing down f first so I don't forget it. X times, the 1/3 comes down. What's inside stays the same. Nope. Subtract 1 from the exponent. So it's now to the negative 2/3 power times the derivative of what's inside, which is 2x. All my parentheses are closed. The numerator's done. The denominator is g squared, so that'll be x squared plus 4 to the 1/3 power squared. It's beautiful, isn't it? Calculus is over. F prime of x, algebra time. This first term turns into what? Okay. Minus. The second term will simplify. This is all multiplication here. It's a negative x times a positive 1/3 times a positive 2x. So 1/3 times 2 is 2/3. X times x is x squared times x squared plus 4 to the negative 2/3 power. That was like a miraculous 5 seconds of handwriting there. That looks pretty good, actually. Divided by, Multiply exponents there. You have a power to a power. So x squared plus 4 to the, what's 1/3 times 2? 2/3. Yeah. Multiply when you're raising a power to a power. Okay. Factor out least powers. And I'm talking about in the numerator here. F prime of x equals? What's the least power? It's actually negative 2/3 that I'm going to factor out. The least power, positive 1/3, negative 2/3 is definitely negative 2/3. Okay? That's the lowest exponent, or the furthest on the left on the number line. That's what I mean by least powers. So I factor out x squared plus 4 to the negative 2/3 power. Open up parentheses, what's left over? X squared plus 4 to the what power? So we factored out negative 2/3 plus what gives me positive 1/3. It has to be 3/3, which is 1. So that makes that exponent 1. Okay, continue. By the way, I need a bigger parentheses there. Okay, minus 2/3 x squared. And that's it, because we factored the whole thing out there. And that's all divided by the x squared plus 4 to the to the 2/3 power. Now what? We have like terms to combine here. And we have a negative exponent here. So f prime of x, don't panic, we're almost there. You're seeing the things you should be seeing. This moves to the denominator. In the numerator, I have x squared minus 2/3 x squared, which gives me, that's a 1 minus 2/3. That's a positive 1/3 x squared plus 4. All over the x squared plus 4 to the 2/3, that's this one, times x squared plus 4 to the 2/3. So yeah, this is the like base here. When you have like bases, you do what to the exponents? You add them. Technically what you have is x squared plus 4 to the 2/3 squared. In that case, you would then multiply the exponents. Either way, you get the same answer. This becomes 4/3 in the exponent. So, let me rewrite that. I have the 1/3, which by the way is kind of a bad thing. We need to take care of that. Over x squared plus 4, now to the 4/3 power. I do want to take care of that fraction, the 1/3, but I can't just move 3 down. If this was one term, then sure, that 1/3, the 3 would go there. But this is not one term. I need to factor out the 1/3 before I can move it down. Now, if I factor 1/3 out of this coefficient will become a 1. What will this coefficient become? No. In other words, if I send the 1/3 back in, I need whatever this number becomes to turn back into 4. 12. So now, I factor the 1/3 out. This is actually going to be 1/3 parentheses x squared plus 12. Now the 3 can go into the denominator. The numerator is x squared plus 12. The denominator is 3 times x squared plus 4 to the 4/3 power. No, it's awesome. Don't you feel relaxed right now?
No.
Just keep breathing. You'll be fine. All right, be excited. There's no roots in this one. So let's just take a look at this function and try to figure out what our plan of attack is going to be. Where do we start? Why is it chain rule? I have some stuff to a power. That is the general power rule. So I'm going to start taking the derivative using the general power rule. As I go along, I'm going to have to use the quotient rule.
So you pretty much work like outside in.
Yeah, what gets me started? I have some stuff to a power. That's chain rule. Now as I'm going along, once I start taking the derivative of what's inside, that's going to be quotient rule. And that's going to be super fun. So f prime of x equals. Good. The 2 comes down. Parentheses. What's inside stays the same. 3x minus 1 over x squared plus 3. Decay the exponent by 1, so it becomes 1, which is nice. Then, the derivative of what's inside. Look at that nice giant parentheses there. To take the derivative of what's inside, we need the quotient rule. Now, the quotient rule is not that big a deal here. Look, f prime is what? 3 times x squared plus 3, the original g. Now what? Minus 2x, that's g prime, times 3x minus 1, the original f, all over x squared plus 3 squared. That wasn't that bad.
Okay.
You just got to see what you have to do as you go along. Calculus is over.
Say that, I just don't. That makes me.
This isn't that bad.
I wanna go.
This isn't that bad. There's no rational exponents here. Okay, so I want to leave that 2 out front for now. Just leave it there. I'm going to leave this alone. 3x minus 1 over x squared plus 3. I'm going to simplify the numerator over there. So if I distribute that 3, I get 3x squared plus 9. If I distribute the minus 2x, I get negative 6x squared plus 2x. So now I'm going to combine like terms and finish off the numerator here. Negative 3x squared plus 2x plus 9. All over x squared plus 3 squared. So now I can multiply those two factors together. Huh? No, there's not an or. I'm going to multiply these two factors together. F prime of x equals. Look at the denominators here. X squared plus 3, x squared plus 3 squared. If I multiply the denominators together, x squared plus 3 cubed.
That's the only thing I want to show. Okay.
Now I got to take out the numerator. The 2 is in the numerator, the 3x minus 1 is in the numerator, and this mess right here is in the numerator. So, 2, 3x minus 1, negative 3x squared plus 2x plus 9. Done. That's it. If you're to look in the back of the book might try to make this positive by factoring out a negative 1, which would make that 2 out front negative. And then this would be positive, this would be minus, this would be plus, okay? So if you look in the back and you see signs that are different, it might be that that's what they did. So just watch out for something like that. But they're not going to multiply out something like this. Leave it. Simplify the denominator here to the third power. Leave this the way it is. You're good. Check the back of the book. It'll match. If it doesn't, then maybe they distributed that 2 in and that would be it. But what they're not going to do is this. Okay? All right.